Question 1. SKU selection. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. The first question asks, a company is deploying a new, mission-critical e-commerce application that requires high availability and must automatically handle traffic spikes during sales events. Which application gateway SKU should they choose? Let's analyze option A, standard V1. This is incorrect because the V1 SKUs are legacy. They do not support autoscaling, a key requirement for handling traffic spikes, nor are they inherently zone redundant for high availability. Option B, WAF V1, is also incorrect for the same reasons. It's a legacy SKU lacking the required modern features of resilience and automatic scaling. Option D, Basic, is incorrect because Basic is not a valid SKU tier for the application gateway service itself. You might see Basic for other Azure services like public IPs, but not here. This leaves the correct answer, C, WAF V2. This SKU is the perfect fit. The V2 component provides both zone redundancy for high availability and autoscaling to manage traffic spikes automatically. The WAF component adds the essential web application firewall to protect a public-facing e-commerce site. Question. Subnet config. This question asks, an engineer is trying to deploy an application gateway into an existing VNet and the deployment is failing. The target subnet A10.0.1.0/24 already contains two virtual machines. What is the most likely cause of the failure? Option A is incorrect because a /24 CIDR block provides over 250 IP addresses, which is generally more than sufficient for an application gateway, even with autoscaling. Option B is incorrect because while using a descriptive name like App Gateway Subnet is a best practice, it is not a technical requirement. The subnet can have any valid name. Option D is incorrect as Azure Bastion is a separate service for secure virtual machine access and has no bearing on the deployment of an application gateway. The correct answer is C. The subnet is not dedicated to the application gateway. Azure enforces a strict rule that an application gateway must be deployed into its own empty, dedicated subnet. This is because the Azure platform needs complete control over the IP space to manage the gateway's underlying infrastructure for tasks like scaling and patching. The presence of other virtual machines violates this rule and causes the deployment to fail. Question 3. Service choice. The question is, you need to load balance traffic for a new web application. The solution must provide protection against SQL injection attacks and route traffic to different backend servers based on the URL path. For example, /app versus /API. Which Azure service should you use? Option A, Azure Traffic Manager, is incorrect. It is a DNS-based global load balancer and does not have an integrated web application firewall to protect against SQL injection. Option B, Azure Load Balancer, is incorrect. It is a Layer 4 service, so it cannot inspect HTTP traffic to make decisions based on the URL path, nor does it have a WAF. Option D, Azure Firewall, is incorrect. While it is a security service, it is a network firewall, Layer 3/4, and not a web traffic load balancer designed for URL routing. The correct answer is C, Azure Application Gateway. This is the only service in the list that operates at Layer 7 and provides both an integrated web application firewall, WAF, for protection and URL path-based routing capabilities, meeting all requirements of the question. Question 4. Multi-site hosting. This question asks, how can you configure a single application gateway to serve traffic for Contoso.com and Fabricam.org from the same public IP, directing each to its own set of backend servers? Option A is incorrect because path-based rules are used for routing based on the URL path, for example, /images, not the domain name of the website. Option B is incorrect because deploying two separate gateways is inefficient, more expensive, and more complex to manage. The service is specifically designed to handle this multi-site scenario on a single instance. Option D is incorrect, as using different front-end ports is not a standard web practice and leads to a poor user experience. Hostname-based routing is the standard method. The correct answer is C. Create two multi-site listeners, one for each host name. This is the exact design pattern for multi-site hosting. You create a listener for Contoso.com and another for Fabricam.org. The gateway inspects the HTTP host header of the incoming request and matches it to the correct listener to route the traffic to the appropriate backend. Question 5 to 502 errors. The scenario is: users are reporting 502 bad gateway errors. The backend servers are running, but the application gateway's backend health view shows them as unhealthy. What is the most likely cause and the first thing you should check? Option A is incorrect because a WAF block typically results in a 403 forbidden response to the client, not a 502 error, which indicates a backend communication problem. Option B is incorrect because an undersized SKU would lead to poor performance and dropped connections, but it does not usually cause health probes to fail if the backends themselves are responsive. Option D is incorrect, as an expired Secure Sockets Layer certificate on the gateway would cause certificate errors in the user's browser, which is a client-side issue, not a 502 error. The correct answer is C. The Backend Subnets Network Security Group, NSG, is blocking traffic from the gateway. This is the most common cause for this specific scenario. If the virtual machines are running but the gateway's health probes cannot reach them, it is almost always a network block. The NSG on the backend subnet must have a rule allowing inbound traffic from the application gateway's subnet on the required port. Question 6. Session affinity. The question asks: an application requires users to remain connected to the same backend server for the duration of their session to maintain shopping cart data. How do you configure this feature? Option A, connection draining, is incorrect. This feature is used for graceful server maintenance, not for managing user sessions. Option B, path-based rule, is incorrect. This is used for routing based on URL, not for maintaining user sessions with a specific server. Option C, health probe configuration, is incorrect. This affects how the gateway determines server health and has no impact on session persistence. The correct answer is D. Enable cookie-based affinity in the HTTP settings. This feature is designed for this exact purpose. Often called sticky sessions, it instructs the gateway to issue a cookie to the client. The gateway then uses this cookie to ensure all subsequent requests from that client are sent to the same backend server, preserving session state. Question: backend security. This question asks: what is the best practice for ensuring that traffic can only reach your backend web servers through the application gateway? Option A is incorrect because placing a deny all rule on the gateway's own subnet would prevent the gateway itself from receiving any traffic. Option C is incorrect because this configuration is explicitly forbidden by Azure. You cannot deploy other resources in the dedicated application gateway subnet. Option D is incorrect because while Azure Private Link is a security feature, an NSG is the primary and most direct tool for this specific network isolation requirement between subnets. The correct answer is B. Configure an NSG on the backend subnet to allow traffic only from the application gateway's subnet. This is the definitive best practice for creating a secure perimeter network. You apply an NSG to the application's subnet with a rule that allows inbound traffic only if the source is the IP address range of the application gateway's subnet. A lower priority deny rule then blocks all other traffic, preventing any attempts to bypass the gateway. End-to-end secure sockets layer. The question is: a security policy requires that all application traffic must be encrypted at all times, both on the public internet and within your private virtual network. Which feature should you implement? Option A, secure sockets layer termination, is incorrect. In this standard configuration, the connection from the gateway to the backend is unencrypted, using plain HTTP. This violates the security policy. Option B. WAF in prevention mode, is incorrect. The WAF is a security feature that inspects traffic, but it doesn't determine the encryption state of the backend connection. Option D. A wildcard certificate, is incorrect. This is a type of certificate for securing multiple subdomains. It doesn't define the encryption behavior between the gateway and the backend. The correct answer is C. End-to-end secure sockets layer encryption. This is the only configuration that meets the stringent requirement. With end-to-end secure sockets layer, the gateway terminates the client's secure sockets layer session, inspects the traffic for WAF and routing rules, and then re-encrypts the traffic before sending it to the backend server. This private gateway. The question asks, a company has an internal-only HR application that should not be accessible from the internet. However, they still want to use a WAF to protect it from internal threats and use advanced routing. What is the most appropriate configuration? Option A is incorrect because using a public application gateway unnecessarily exposes a public endpoint and increases the attack surface, even with NSGs in place. Option C is incorrect as a public Azure load balancer is the wrong service. It's layer 4 and has no WAF, and is public-facing. Option D is incorrect because Azure Front Door is a global, public-facing service designed for Internet applications, which is the opposite of the stated requirement. The correct answer is B. An application gateway configured with only a private front-end IP address. This is the perfect architecture for this use case. By not assigning a public IP, the gateway becomes an internal-only service. It provides all its advanced features like WAF and routing for traffic originating from within the virtual network, but without any public exposure, meeting all the requirements securely and efficiently. Question 10. Graceful maintenance. The final question asks, you need to perform maintenance on a backend server. How can you remove it from the backend pool without abruptly ending active user sessions? Option A is incorrect because abruptly stopping the virtual machine will end all active connections, causing errors for users. Option C is incorrect. While changing the health probe to make it fail might cause the server to be marked as unhealthy, the gateway may still abruptly cut active connections. This is not the designed feature for this task. Option D is incorrect. Deleting the server from the pool immediately is the worst option, as it provides no grace period for active sessions, causing instant errors for users. The correct answer is option B. Enable connection draining, then remove the server from the pool. This is the correct and professional procedure. Connection draining tells the gateway to stop sending new requests to the server but to keep existing connections alive for a configured timeout. This allows active users to finish what they are doing. After the grace period, the server can be safely shut down or removed without any user impact. Thank you for your attendance. Please consider subscribing to the channel.